Today we're going to be talking about multiplying and dividing rational expressions. And we start off the section by simplifying rational expressions. So when you look at this rational expression, the entire thing needs to be completely factored. So when you look at this bottom piece can still be factored. So we go ahead and we factor that bottom piece. Remember, that's a difference of two squares. So that's y minus 3 and a y plus 3. Now you can only cancel factors. Each one of these quantities in parentheses is what we call a factor. So I can cancel the y plus 7s. So now looking at this, there's nothing, the y minus 3 and the y plus 3, there's nothing that could cancel up top. So looking at that, we can now write this in its most simplified form. Don't worry about multiplying everything back through, because this is showing me that all your factors have been canceled. So now part B, under what conditions is the expression undefined? It's any time the original is equal to 0. I should say the bottom of the original. So let me write that. The bottom, or the denominator, of the original before you factored anything. Okay? Before you even canceled. So what you can look at is you can look at this factored piece there and set each one of those quantities equal to 0. So y cannot be equal to -7, 3, and a -3. Okay, so now looking to see where are, for what values of p is this function undefined. So you want to look at when the bottom of your original equals 0. So let's factor that to -5 and p plus 3. So p cannot equal 5 and -3. Now I also wanted you to simplify. So now look at this. We have p minus 5. We have p plus 3 is our bottom. We already factored. We did that work right there. Now factor the top. P plus 3, p minus 1. Remember that these numbers here need to multiply to be -3, but add to be +2. That's why my larger of the two numbers is positive. The p plus 3's cancel, so we are left with p minus 1 over p minus 5. Okay, simplifying this example. Again, just factor. When you look at the top, there's a common factor of a to the 4th that I can factor out. I'm left with a b in the first term and a -2 in the second term. Now looking at the bottom, factor out what's in common. I have an a to the 3rd, then I have a 2 minus a b. That a to the 3rd can cancel and be 1. That a to the 4th can cancel and be an a. So we are left with a times b minus 2 all over 2 minus b. Now look at this. When you're looking at this top, b minus 2 and 2 minus b, notice how those are the same values, just opposite signs. So if I factor out a -1 from this b minus 2, so I have a -1 that I factored out, I'm going to put it in front of the a. I'm left with a -b plus 2. Or rewriting that, what we have is we have a 2 minus b. Again over a 2 minus b. So now even more cancels, and we're just left with a -a. Our next example. What you want to look at when you're canceling here. Think about when we're multiplying. I'm going to think of 2/3 times by 9/4. What you do first to reduce this, you take and you reduce the 3 and the 9, and you reduce the 1 and the 4, and then you just multiply across. The same process happens here. So cancel out common factors with your numbers. The 8 can become a 1, the 16 can become a 2. The 7 can become a 1, and the 21 can become a 3. Now remember, you're multiplying. Now let's look at what other factors I can cancel. The y to the third and the y squared can cancel y squared to 1. Y to the third can cancel to be a y squared. X and x to the third. X to the third can become x squared. X can become a 1. Now just multiply all these numbers across. So I have 1 times 1 times 1 times 1. I have a 1 on the top. On the bottom I have a 3 times a 2, so that's going to be a 6. And then we have an x squared, and I just realized I canceled this y to the third and y squared. That just cancels to be a regular old y. Now B, when you're dividing fractions, you first have to adjust your problem. So you keep the first term or first fraction the same. Change your sign to multiplication, flip the second fraction. And when I first started here at De La Salle, one of my guys came up with, or told me, keep it, change it, flip it. Keep the first, change the sign to multiplication, flip the second one. Now go through and cancel. Cancel with your numbers. 1 and 2. 1 and 2. C squareds just cancel. Your m cancels to be a 1. M to the fifth is going to be m to the fourth. K squared, there's nothing that cancels with k squared, so don't forget about that. But the d and the d squared cancel. So now just multiply across. 2 times 1 times k squared, don't forget about this k squared, times 2 times d is 4k squared d. All over I have a 1. There's a 1 there, so all those are 1s. All I have left over is m to the fourth. Now one that's a little bit more complicated. You have to factor these first. They have to be in factors. So k minus 3 doesn't factor. K plus 1 doesn't factor. 1 minus k squared, that's a difference of two squares. K squared minus 4k plus 3, that's going to become a k minus a 3 and a k minus a 1. So now let's look at what I can cancel. K plus 1's cancel. K minus 3's cancel. So what am I left with? I'm left with 1 minus k over k minus 1. Now let's look at that. That's like that example that we had earlier, where the variables and the numbers are all the same, just I have opposite signs. On the top, that 1 is positive. On the bottom, the 1 is negative. On the top here, the k is negative. Down here, it's positive. So if I factor out a -1 from this quantity, the top, that changes the signs so that we can then end up canceling and get -1. Okay, this example is just like the other example we did. We have to keep the first fraction the same. Change their sign to multiplication. Factor your second fraction. So now, first fractions factor. So factor everything. I'm going to have a d plus a 2 and a d minus a 1. I have a d plus 2, a d plus a 1. So now again, go through and cancel. D plus 3. D minus 1 and d plus 1 don't cancel. Those aren't exactly the same. And I can't factor out a negative from one of them to get the other one because the d's are both positive. So those cancel. So I'm just left with a 2 d plus 1 over a d minus 1, and leave that in the factored form. So we are done. Okay, our next one. This one is really a division. Take the numerator, which is x squared divided by 9x squared minus 4y squared. That's really a divided by sign. Divided by the bottom, x cubed times 2y minus 3x. So again, it's that same process. Keep the first one the same. Change your sign to multiplication and flip the second one. Now it's just a matter of going through and factoring. There's nothing to factor with the x squared. This bottom is a difference of two squares. The first term's a perfect square, second term's a perfect square. And make sure you factor it correctly. It's not a perfect square. There we go. 2y. 3x plus 2y times my x to the third, 2y minus 3x. Okay, x squared can cancel and become a 1, leaving that x cubed with just an x. Now, again, notice, look at this 3x minus 2y and the 2y minus 3x. Same exact values, just their opposite signs. And here the 3x is positive, over here it's negative. Here the 2y is negative, there the 2y is positive. So that can cancel and become a 1 and a negative 1. You could also cancel it the other way. So I'm just left with a negative 1 times an x and a 3x plus 2y. There are your lesson questions for the day. Please make sure those are submitted on time.